All right, hi 20-1 students, and welcome to your very first set of video lessons. So today we're going to be we're starting with chapter 1, and we're going to be looking at sequences and series. So to start out today, we're going to be looking at arithmetic sequences. So I've included in your note package basically a breakdown of how much time you should be spending on each section, although of course you can refer to the course outline to double check, because basically I just said how much time you should spend on each of these. But if I gave you additional time in the course outline, then that means that you have a little bit more time for review, so you can basically count that time in kind of between number 6 and number 8. Looks like I got my numbering wrong there. We're off to a good start. But yeah, so basically you can just if there's any extra time in the course outline, just assign that to being review time. So I've also included these the days, and then I'll have the assignments at the end of each set of notes, but you can always refer back to this front page too for all of your assignments. So let's get started on lesson 1.1, which is arithmetic sequences. At the beginning here, I'll always have a list of learning outcomes. Usually how this will work best is the learning outcomes are basically what the government says you need to know. So this is what we can test you on as teachers. So essentially at the end of this lesson, I would recommend coming back and asking yourself, can I derive a rule for the general term of an arithmetic sequence? Can I determine these different variables in an arithmetic sequence? Because these are all things you should be able to check off and say yes, I can do that. Once you can do that, you know that you're ready for, those components that will definitely be testable. Okay, so to start out with, we're going to look at a little bit of a question that can lead us into an understanding of what arithmetic sequences are. So we're talking about comets, which are frozen lumps of gas and rock, and are often referred to as icy mud balls or dirty snowballs. In 1705, Edmund Halley predicted that the comet seen in 1531, 1607, and 1683 would be seen again in 1759. So it turned out that his prediction was accurate, and so the comet was later named in his honor. And the years in which Halley's comet has appeared form the terms of an arithmetic sequence. Okay, and we're going to figure out what that means by looking at how this works. So how many years passed from the first recorded comet sighting to the second? So our first one was in 1531, our second one is in 1607. So if we want to figure out how many years are between those, that means we're looking for the difference. And remember, in math, the difference always means subtracting. So you want to take the larger number, 1607, and subtract the smaller number, 1531. And we'll find that that gives us a total of 76 years. Okay. Then how many from the second to the third? So again, we're looking for the difference. So it's going to be 1683 minus 1607. And again, we'll find that that gives us 76 years. Okay, so when we see this, it kind of seems weird that this guy got to have a huge honor of being able to predict when the next one would happen, because you'd think that that wouldn't be that hard to put together. But so how did Halley determine the next time the comet would appear? Well, why did I just say that it seems like we would probably be able to figure it out? If the time between the first two was 76, the time between the second two was 76, chances are pretty good that the time is going to be the same from the third to the fourth, right? So essentially what he would have done is notice this pattern and then use that pattern to predict the next appearance, right? So added 76 to the time of the last sighting, which was in 1683, to get his prediction of 1759. One thing I will tell you guys when we're going through these notes, sometimes if I have something that has to be written out that's going to be a long sentence, I won't always write it out during the video, just because I don't want to waste your time while I'm trying to write something out. But when you look at the filled in notes that are available on the website, the proper written out sentence will be there. Okay, so the other thing to just be aware of as you move through these is that the filled in notes that you can find on the website, if you want to have a good understanding of how I would expect you to answer like written questions on a test, so like the thoroughness and the precision, you should be looking at those filled in notes, because I do expect that when you have written questions, you're fully answering the question properly, and that's what I do in the written out notes. But again, I don't want to waste your time during the video, so this will be the only time I explain that, so that I don't have to waste your time every time explaining to look at the filled in notes. All right, so the next one is, can you predict the next time that Halley's Comet would appear, right? And so if we want to predict the next time, if you want, you can pause the video and see if you can figure out when is going to be the next appearance of Halley's Comet, like for us, okay? And then if you unpause the video, basically what would you do? Well, if we know that his prediction that it would appear in 1759 was correct, then we would know that after 1759, we would expect there to be another 76 years before the next sighting. So that would be in 1835. And then after 1835, there'd be another 76 years. So it would appear again in 1911. After 1911, another 76 years, so it's going to appear in 1987. And then, so we're past 1987, so we still need to add one more, 76, and that's going to bring us all the way to 2063. So for us, that's going to be the next appearance where we're going to see Halley's Comet. Okay. All right, so let's go through some of the definitions now here. So we kind of have an idea of what an arithmetic sequence is from this investigation, right? We can basically see, and maybe you can even make a prediction, like what do you think an arithmetic sequence is based on the questions we just did. So we know that a sequence means something that's going in an order, right? And so with an arithmetic sequence, basically what we're doing is we have an ordered list of objects. So in this case, it's years. And how are we finding what each next object is? Well, we're finding it by adding the same number to each previous term, right? So if we started with 1531 and we add 76, we get the second term. And then if we add 76 to 1607, we get the third term, and so on and so forth, right? So a little bit of terminology. A sequence is an ordered list of objects, and it contains elements or terms that follow a pattern or a rule to determine the next term in the sequence. So when we're talking about a sequence, we're always thinking about a pattern of numbers, right? So the terms of a sequence are labeled according to their position in the sequence. So basically all I mean there is like, if we think back to this example here, the terms would be the years where it appeared, and they're going to be labeled according to their position. So basically if this was our first one, we would call this one term 1. This one is going to be term 2, term 3, and then his prediction is going to be term 4, and then we would carry on that list down here. Okay. So the first term of the sequence is always T1, and that's going to be important because we use that in one of our formulas. The number of terms in the sequence is referred to with the variable n. So n refers to the number of terms. The general term of the sequence is Tn. So basically, general term means like, how could we determine any one of the terms that's not term 1, basically. So Tn could refer to any term in the sequence. The n represents that it could be any number. And then if you choose a specific term, then this can become like T3, T4, but because n is a variable, it can apply to any one of those. Okay, so that's why we say the term is dependent on the value of n. Now we have two kinds of sequences. We could have a finite sequence, and finite just means that it's going to have a finite number of terms, which means that it will end, right? So in this sequence we have 2, 5, 8, 11, 14. That's our whole sequence, and 14 is our last term, right? So it ends. If we have an infinite sequence, you can probably guess from the term there that it's just going to go on forever. So every term is followed by a new term. So 5, 10, 15, 20, and it can go on indefinitely. Okay, so right now with arithmetic sequences, this isn't going to be super important, but when we get a little further on in the unit, the finite and infinite is going to become pretty important. So a few things to remember. An arithmetic sequence is an ordered list of terms in which the difference between consecutive terms, so basically the amount that they're increasing by or decreasing by, is constant. So we're always using the same number. Like for example, in the comet example, it's always 76 years is always the difference between the terms, right? So the same value or variable is added to each term. Now sometimes it's going to be like subtracting, but really all that means is you're adding a negative term, right? So we can say that we're always adding a value to the terms to create the next term. So the constant that we're adding is called the common difference. So it's the difference between consecutive terms, and it's the same for all of them, so that's why we call it common. If you subtract the first term from the second term for any two consecutive terms in the sequence, you will arrive at the common difference. So all we mean by that is, like, you could subtract T1 from T2 if you're given those first two, but if you were only given T2 and T3 and told there was a T1 you didn't know about, you could still do T3 minus T2 to find the common difference, or T4 minus T3, right? So as long as they're consecutive terms, you can subtract the previous one from the latter one, and you will get your common difference. Let's see, you will arrive at the common difference, and the common difference is represented with the variable d. So the d value may be positive or negative, and that's where we would come up with, are we adding or subtracting? So we kind of always say we're adding, but if we're adding a negative number, of course, we're kind of technically subtracting. Okay, so we have a formula that we can use to work with to solve problems involving arithmetic sequences. And so we say the general term of an arithmetic sequence is, so remember we mentioned Tn is the general term because it can refer to any term in the sequence depending on the number of it. But you can calculate that general term by finding the first term, adding which number term you're on. So these two values have to kind of match up. So like, for example, if we were looking for T4, so if our Tn was T4, then we would have to make sure that n here was 4, right? So the little value here is going to match up with this n here, of course, minus 1, and then you're going to multiply it by the common difference. Okay, so basically if we think about for Halley's Comet for this term, if we wanted to make the general term, what was our first term? It was 1531. Okay, so we would say Tn is equal to T1 1531 plus, now if we want to just keep it the general term, we want to make a formula for this Halley's Comet, but we're not going to specify which number of term we're looking for. Then we're going to still keep it as n minus 1, and then we're going to multiply that by the common difference, which we said was 76 years. Now, whenever you give the general term, so if you're ever asked for the general term as a question, which I can basically tell you you will be in the test, so you want to know this information for sure, what you need to do is you never want to leave it like this. You want to simplify as much as possible. So basically what you would do now is, if you have a set of brackets, remember you always need to multiply it by both. Whatever's being multiplied on the outside needs to multiply by both things inside the bracket. So if we simplify this, we're going to see Tn equals 1531 plus 76 times n is 76n. And then negative 1 times by 76 is minus 76. Okay. Can we leave it like this? Well, no, because remember, if we're simplifying, we're always combining like terms, which means if I had another value that had an n being multiplied by it, I would add or subtract it from this value. But since this is the only one, it can stay the same. However, I have two values that are just number values. So those are like terms that I can simplify. So I'm basically going to go 1531 minus 76 gives me 1455. So I'm going to say Tn equals, this is my new value combining those two numbers, so it's going to be 1455 plus 76n. And so now this is my general term for that sequence that we looked at with Halley's Comet. And so basically now if I wanted to solve for any one of the values, like say if I wanted to figure out what the fourth term was, I would just plug in 1455 plus bracket 76 times by, if I want to know the fourth term, I multiply it by 4, hit enter, and I get 1759. And as we know, T4 was 1759. So essentially this is a way that I can solve for any one of the terms in the sequence once I have this formula set up. Okay, so important for you guys to know, this is our formula for the general term. If you find a general term, you leave the variables in there because it's general, right? We're not making it specific to any certain term. And then the other important thing is make sure you simplify as much as possible. Okay, so with that, let's try some other examples. So the first one is find the common difference in the sequence. So we have 10, 16, 22, 28. The difference is always going to be whatever term you want to choose minus the term before it. So it's going to be Tn minus 1, right? This is just a fancy way of writing it out. All you have to remember is that you have to find one term and subtract the term before it. So essentially we could find the difference by doing 16 minus 10, which gives us 6. You could do it by doing 22 minus 16, 22 minus 16, which will give you 6. You could do it 28 minus 22, etc. Right? So basically we would say the common difference is 6. Okay, so considering the sequence, it's the same one as we had before. We want to find the general term. So we already solved for the difference. Our general term is always going to be Tn equals T1 plus n minus 1 times by d. So the only value you plug in when you're solving for the general term is the T1 and the d, right? You always leave the n as a variable. So we can say Tn equals T1, which is 10, plus n minus 1, and then we want to multiply it by the difference, which we just solved for as being 6. And then remember, we need to simplify. So really important, we want to first multiply our 6 through the brackets. So 6 times by n is 6n. And then 6 times by negative 1 is negative 6. Okay, always remembering to keep your positives and negatives together. So if this is a positive 6 and it's being multiplied by positive n because there's no negative out front here, then you're adding it. But because this is a negative 1 times a positive 6, we have a negative 6 here. Okay, and now we just want to combine like terms. So we have two number values here, And again, always keep in mind that the value ahead of the number is what stays with it in terms of adding or subtracting. So if I have this 10 here, there's no negative in front, so it's positive 10, and then negative 6 here. So positive 10 plus negative 6, or positive 10 minus 6, is going to be 4. So I have Tn equals 4, and then plus 6n. And that's our general term. Now, if you were doing this and you came up with Tn equals 6n plus 4, does that matter that it's different? No, right? Because anytime we're adding numbers together, it doesn't matter what order they're in. Like 3 plus 4 is 7 and 4 plus 3 is 7. It doesn't matter. Okay, so either one of those is fine as an answer. Okay, let's look at another example. So in one section of a stadium, there are 30 seats in the first row, 32 in the second, 34 in the third, and so on, and there's 60 rows. So the first 5 terms of the sequence would be what? Well, we start with 30, and then we go 32, and then 34, and then what's going on here? So basically we can see that 32 minus 30 gives us a difference of 2. So each one is going up by 2. So we're going to go 36, 38. So if we want to write the general term, it's going to be Tn equals T1, so 30, plus n minus 1, so that never changes, multiplied by our difference, which we said was 2. Multiply this out is the next step. So Tn equals 30 plus 2 times n is 2n. Negative 1 times 2 is negative 2. And now I want to combine like terms. So I'm going to do Tn equals 30 minus 2, which is 28. And then we have plus 2n. So there's our general term. And the general term is what's going to help us determine how many seats are in any one of the rows we're interested in. So in this case, we're looking at the 60th row. So basically, we're looking for T60 is going to be equal to 28 plus 2 times by n, which is 60. And so if we do that, just make sure you're always being careful with your order of operations. So it's going to be 28 plus 2 times 60 is 120. So always multiply first, and then we can do our adding. So T60 is going to be equal to 148 seats in the 60th row. So again, check those filled in notes because they're going to give you the proper way to answer a written question, which would be to say there are 148 seats in the 60th row. Okay, just a couple more examples here. One term in the sequence 10, 13, 16, etc. is 130. So now we're looking at a little bit of a trickier question because they want us to figure out which term is that. So first of all, we want to figure out as much as we can about this. So one of the things we know we can solve for is the difference. So difference is going to be 13 minus 10 is 3. So we have a difference of 3. And then what else do we know? We know T1 is 10. Okay, and we are also told one term is 130. So we want to know what Tn is equal to 130. And basically we want to know what n is for this, right? We want to know which number of term it is. So if we look at, let me just pull this back. If we look at, here I'll bump this down a little bit. We are given this formula, right? So we know what Tn is, we know what T1 is, we know what D is. We need to solve for n. So we can use this formula, but we are going to have to rearrange it so that we can isolate n. Okay, so essentially there's like multiple ways you can do this. First, you can rearrange this whole thing to solve for n, so you're just using the variables and moving them around. Personally, what I like to do is make my general term first so that it's simplified, and then it's easier to solve it algebraically. Okay, so basically I would say Tn, in this case we said is 130, and that's equal to t1, which is 10, plus n minus 1, so that's going to stay the same, n minus 1, because we don't know what n is, and it's going to be multiplied by the difference, which is 3. And now I'm going to simplify. 130 equals 10 plus 3 times n, so plus 3n, and then negative 1 times 3, so minus 3. Now I'm going to combine like terms, so 10 minus 3, 130 equals 7, 10 minus 3, plus 3n. Okay, so now I have my general term, and I can solve for n algebraically. So remember, when you're using algebra, first you're basically doing BEDMAS backwards, so you first want to do any addition or subtraction. So because 7 is being added to the term with the variable, we want to subtract it to remove it. So minus 7, and then what we do to one side, we do to the other. So we're going to end up with 130 minus 7, which is 123, is equal to 7 minus 7 is 0. So we're just left with 3n on that side. Now there's nothing left to add or subtract, so the next thing we do if we're working backwards in BEDMAS is divide or multiply. Because 3 is being multiplied by n, we want to do the opposite operation to remove it, so we want to divide it. And again, we always do the same thing to both sides. 3 divided by 3 is 1, and 1 times by n is just n. So now we have n is equal to 123 divided by 3, which is 41. So now we know that term 130 is the 41st term in this sequence. Okay. Okay, here we have a set of diagrams. So these U shapes that are made out of stars. And they want to know how many stars are in the fourth diagram. So like I said, with sequences, we're looking at a pattern, right? So what you need to do is go in and look at what the pattern is. So we want to figure out how many stars are in each diagram that we can see already. So there's 3, 6, 7 in the first one, 4, 8, 10 in the second one, 5, 10, 13 in the third one. Okay, and so what's happening here? Well, every successive diagram that we see, we go from 7 to 10, so that's going to be an increase of 3. 10 to 13 is an increase of 3. So in the fourth one, we would expect to see an additional 3 stars, right? They're adding 1 on each side and 1 on the bottom every time. So we go from 13 to 16 in term 4. Okay, so 16 stars. What is the general term for this sequence in the numbers of stars? So again, we want to come up with number values for as many variables as we can. So we know T1 is equal to 7 stars, right? What's the difference between these? Well, we said that the difference was 3. And then if we just always, like especially when you're first starting out, you'll always want to refer back to this. You should also have it, of course, on your formula sheet, which, I didn't actually grab. Did I? Oh yeah, I did. So here's your formula sheet as well. So you can see that we have our first formula here. And that's actually, this is a good chance to remind you guys, make sure you're using your formula sheet as you're working through this material, because if you're using it when you're working through, then when you get to the test, you'll always know where all these formulas are, and it will enable you to work a little bit more quickly and efficiently on the test. Okay. Okay, so what is the general term? So like we said, we have Tn is what we're looking for the general term. So T1 and D, and we don't need to know n. So now we can write out our general term. It's going to be Tn equals T1, which is 7, plus n minus 1. And then times by D, which is 3. Okay, and then simplify. So Tn equals 7 plus n times 3 is 3n, minus 1 is negative 3. Combine your like terms. Tn equals 7 minus 3, which is 4, plus 3n. So there's our general term. How many stars are in the 25th diagram? So basically we're looking for, and it's important to make sure you keep track of this. So 25th is going to be our n value. The number of stars is going to be our Tn. So essentially we can just go T25 is going to be equal to 4 plus 3 times by our n value, which is 25. And so 3 times 25 is 75 plus 4 is 79. So T25 equals 79. If you guys have written, you'll notice I always box in my answers. If you guys are doing written questions on the test, please make sure that before you submit it, you just kind of box in your answer. It makes it, especially if you are not a tidy worker, well, for one thing, you need to work on being a tidy worker because you might miss out on you might miss out on marks from teachers if they can't read your work or figure out like where you were going with stuff. So try to work, like you'll see that as we go through these notes, I'm always trying to like keep things fairly sequential. Like I write things in the order that you're thinking through, and then at the end I box in my answers. So the more you can write out your answers like this on a written question on a test, the more likely you are to get full marks, because if I can follow what your thinking process is, even if you made a mistake, like say you accidentally put in -4 here, you just didn't copy it right or whatever, then I would be able to see like, oh, you still had all your math right, but you just like missed out on, so then you might miss out on only a part of a mark. Whereas if I couldn't see if you went just from this to that, but this value is wrong, for example, or this value is wrong, I wouldn't know what your thought process was. So the more you can fill in for written answers on the test, the better, and the more kind of tidy you can put it in, the better. And if your answer is very clear, that's going to make it easier too. Okay, so these are all tips for kind of like test writing. And I mean, based on my experience, they'll help you all the way through, not just high school, but university as well, if you choose to go that way. Which diagram contains 139 stars? So now we're being asked, if this is the term, which diagram would that be? So the diagram number is going to be your n value. So essentially what we need to do now is Tn is 139, which is going to be equal to where's my general term? There it is, 4 plus 3n. 4 plus 3n. So n is the value we're looking for. And so now we just want to start doing algebra to isolate n. So remember, first step is to add or subtract. So we have plus 4 here, so we want to subtract 4 from both sides. 139 minus 4 gives us 135. 4 minus 4 is 0, so 0 plus 3n is just 3n. Then the only thing left to do, these are being multiplied, so we need to divide out the 3. 3 divided by 3 is 1, so we have n being equal to 135 over 3, which is 45. So basically we're looking at the 45th term would have 139 stars, or the 45th diagram, right? Okay, last question here, then we are done. So a furnace technician charges $45 for the house call. So that's just like a flat fee for him coming out, and then $46 per hour. Generate the possible charges, excluding parts, for the first 4 hours of time. So basically, for the first hour, you're going to have his charge for coming to the house plus the first hour, right? So 45 plus 46 gives us 91. What are we going to solve for the next hour? Well, he's going to have his base fee, right, that we started out with for the first hour. What would we add on for the second hour? We're only going to add on the hourly charge after that, okay, because you've already paid for the house call in the first one. So it's going to be 91 plus 46, which will give us 137. And then same thing, so 137 plus 46 for the next one, which would be 183, and then plus 46 for the next one is 229. Okay. let's see, what is the charge for the first 10 hours of time? So which one is 10 hours, or which variable is that referring to? Well, it's going to be the value for n, right? It's going to be 10. So n equals 10. What are the other variables? We need t1, which is 91. We also want to know the difference. So moving into each term, we're adding 46. So that's our difference. Okay, so we want to first of all make our general term and then solve for the variable. So, which is going to be Tn. So Tn is equal to T1, which is 91, plus n minus 1 times by our difference of 46. So multiply out 91 plus n times 46 is 46n. Negative 1 times 46 is minus 46. And then our last step is always to combine like terms. So 91 minus 46 gives us 45 plus 46n. So now if we want to solve for 10 hours, we're looking at T10, right? And it's going to be 45 plus 46 times by the number of the term, which was 10. So that's going to give us 45 plus 460. So always making sure you do your order of operations properly. First multiply, then add. So 45 plus 460 is going to give us 505. And so in a proper written question, you would say the cost for the first 10 hours is $505. Okay. So again, look to the filled in notes to find the properly written out answer. So you guys have an assignment to work through in the textbook. Here's the page number and the questions. These are going to be the ones that will help you out the best. Make sure that when you do each question, you are using the textbook solutions to check your answers so you know you're on the right track. And then if you struggle with any of the questions, like if you just can't get the right answer, even though you've gone back and checked your notes and tried to follow through one of these examples, for example, and you still can't get the right answer, then make sure that you contact me and ask for help in determining that correct answer. Okay? All right, so next time I will see you, we will be looking at arithmetic series, so lesson 1.